Hello and welcome to another C++ tutorial. So this time around we are going to be taking a look at something called the auto keyword. So if you're coming from C# side, auto is quite similar in many ways to the var keyword. So it gives us a way of having a type that is essentially auto-determined based upon how we're using it. And it's really, really handy as a shortcut for sometimes when you're working with really complicated types. But there's a couple of important aspects with how it works that we need to be aware of, because it's a little bit harder to run into pitfalls with var, but with auto there is a couple of pitfalls that we can run into, and it's really important to be aware of those. So let's dive on in. So what we're going to do to start off with is I'm just going to get a couple of extra header files added in here that we'll end up making use of. So we'll bring in a string, and we'll also bring in vector, because we'll end up making use of both of those. Okay, so let's see how we use auto. So how I would work with it, for example, is I could go auto test var1 is equal to 42. So what this will do is it actually determines the type, as I said, based upon how we are using it. So in this scenario, I'm assigning something that would be considered an integer to it. So test var1 is going to become an integer. And I can actually see when I mouse over it, the tooltip specifically says the type there. And so I could easily go and give that a different value if I wanted. So I could go test var1 is equal to 20, like that. And okay, I can output it the same way I normally would. So test var1. So I can do that. So exact same process that I would normally follow. And I can see test var1 is 20. So I can change the values of the auto declared variable. What about changing the type of it? Because var, that's something that we can't do with var in C#. We can't change the type. Can I do that with auto? Well, let's find out. Test var1. So let's see, okay, what if I try and set it to a float? Well, that works, but then in C++, floats will auto-convert to an integer. So that one's obviously safe. But what if I did something like this? Now we can see that is indicating an error. And it's saying we can't assign const char star to an int. So auto cannot change type. So once it's given a type, it's locked to that particular type. What about doing other more complicated things with it? So we can use auto with a string. So I can have auto test var2 is equal to test, and I could output that. So same sort of logic. So it does handle working with effectively any type, which can get really handy when you might have a standard vector of a class, and that class could be complicated, or a lengthy name. Same thing for if you've got dictionaries. Types can get quite lengthy and quite complicated in C++ or in any language, but auto makes it so that we don't need to use the really verbose stuff, so it can actually make it a little bit cleaner and neater our code and easier to read. which is always good. And because the IDE, so Visual Studio does this, I would imagine a lot of other IDEs will be able to do this as well. When you mouse over, it will tell you the actual type that variable is, because that variable type gets locked at compile time. So, okay, that's good. Let's try and test the limits of auto. Let's see what we can do that's a little bit more complicated. So I'm going to have a test integer, and I'm going to set that to 42. And then what I'm going to do is test first with references. So I'm going to have, okay, well, int ampersand, so a reference. So test ref 1. I'm going to say test int. And then, okay, well, if I increment test ref 1, let's output our values here. So we'll have our value for test int, and we'll have our value for test ref 1, and we'll set up so we've got a little bit of spacing and neatness here with this. So we'll have test int is equal to, we output that value, and then we'll do the same with this, just to make it so it's a little bit cleaner and neater for what we're working with. So we're going to just do a standard test with references first. What we would expect is we see 43 output twice here. That's what we should expect to see. And we do. And we'll clean up our formatting a little bit. So, okay, that's good. Let's bring auto into this now. So what I'm going to do is have auto test ref 2. Actually, I'll call this test auto. And test auto 3, because we've already got test var 1 and 2 up here. So test auto 3 is equal to test ref 1. So I'm setting this to be equal to the reference, because what I'm wanting to check here is, okay, does that fact that it's a reference come across? Does test auto 3 also become a reference to test int? And this is something I really recommend when you're experimenting, learning a new language. Test out different things. Try it to see if it, don't just assume, okay, I think it behaves this way. Test it out. Do little bits of test code like this and find out. Because then what I'm going to do is test auto 3. And then I'm going to use a similar line to this, because, so we output test ref, output these, and I'll then put in here test auto 3. So if test auto 3 is also a reference back to test int, then I would expect all of these to be the same value. If, however, what it's done is create a copy of this, then test int and test ref will be exactly the same, but test auto 3 will have changed. So we'll run it, and we can see 43, 43, 44. So assigning a variable that is a reference to an auto does a copy by value. So this will do a copy by value. So it is not a reference. So it's really important. It's actually gone and created a copy. I can, however, use a reference with auto. So what I can do is if I take this block and then bring that here, so we're going to have test auto 4, and I will do ampersand test int. So we declare it as if it was a reference, and then I make this test auto 4. Well, if that's correctly worked as a reference, all of these will be the same value. So I run it, and we can see that unlike the previous line, it has gone and changed the originals. So this will be a reference to test int. So, okay, with references, the main thing we need to watch for is that unless we actually indicate that this is a reference, it will just do a copy by value. So, okay, this is testing it with references. What about with pointers? So what if I do something like this, where I have, okay, int star test pointer 1 is equal to the address of test int, and then I want to increment that value. So I do test pointer 1 with dereferencing it like that, and I'll do the same thing for outputting here as I did earlier. So with this, fairly straightforward. We expect to see the values change because pointers, it's referring back to the original data, so it should change. But let's make sure, again, we're wanting to test that things work. So yep, that's giving us the expected behavior, so that's good. Well, let's try auto, and I'm not specifically putting auto star. So we'll have test auto 5 is equal to test ptr 1. And then similar sort of logic, and I'll use, this one's probably a good one to use. So we'll do the same sort of thing, but I do test auto 5. We'll log out things like test pointer 1. And for our test auto, we'll do the same thing. Test auto 5, but also dereferencing that. So, okay, if this has worked, then all of these will be the same value. And we can see they are. And the reason it works kind of makes sense when we realize what a pointer actually is. The pointer is just the location in memory. So while a reference is still that, the pointer is kind of a little bit more of a rawer version of that, with a lot of without the sort of syntactic sugar around it that a reference does. So it kind of makes sense that this auto really, it's just holding an integer. Now it is able to tell us that yes, this is an int pointer, but it makes sense. It's just a memory address. We're just dereferencing it and treating it like we normally would for a pointer. Whereas with the reference one, it doesn't know and it can't pick up. We see the type there is just int, because when you use a reference, the whole point of it is that you have those by value syntaxes, so it actually treats it as being by value. So important thing to be aware of there with that. So how it gets passed around is really important. And we can see what happened with the copies in that here, but we want to see how it actually can go even more wrong. And the easiest way to illustrate that is we're going to set up a very simple little class, which is going to make it very easy for us to illustrate just how wrong this can go if we aren't aware of things like needing to put the ampersand if we want something to be a reference. Okay, so the class I'm going to create is just going to be a very simple class, which I'll call simple class. And I'm just going to give it a single variable data, which I'll default to -1. Going to give it just a basic constructor that all this does is set the data variable like that. But importantly, I will also give it a destructor. So we'll have a destructor here, and what it's going to do, not that we would normally be outputting text in a destructor, but it's helpful for illustrating this. This isn't a normal thing that you would typically do inside a destructor. But in this case, it helps us illustrate this, but it's just important to be aware that, yes, this is not normal practice outputting to the console in a destructor, and is not something I would generally be looking at doing. So, okay. Now we're going to set up our test with loops. So first we need to actually set up some data. So what I'm going to do is have a standard vector of simple class, and this is going to be data set 1, and I'm going to do data set 1, and I'm going to reserve space for 5 entries, and then I'm going to add them in. Now I'm adding them in using this method mplace, and in particular mplace back, which what that allows me to do is when I provide 1 there, that's actually going to be getting passed in here. So it actually is going to construct a new simple class with that as the data value. So it's really handy being able to have things like mplace back there. And there is just a general mplace function as well. So that's cool. What I would expect if I ran this now is I should see, for when the program exits, there'd be a bunch of destroys, which there is. So that makes sense. If I did something, however, and this is where auto comes in kind of handy for making it shorter rather than writing standard vector simple class, I could do auto dataset 2, it's dataset 1. Now if I did that, see how we get 2 sets being destroyed? It's because it's gone and created a copy. So if I do auto and, then it's going to not create that copy. We can also use const with this as well. So won't change what our output here is, but that can be really handy. That not only can you do auto where it's a reference, you can have auto as a const reference, which is really cool. Where auto comes in really handy is with stuff like of loops. So I could do for auto data, and I say data set 1. Then I'm going to output data is, and we provide the value. Now I have intentionally not put an ampersand here. And I've done that intentionally to illustrate the problem that we will run into. And we can see saying data is 1, and then it's destroying it. And that's because, again, auto will not, even in something like a for loop of that, it doesn't automatically become a reference. We have to explicitly say that it is a reference to this. So really important thing to be aware of. And this is something where it's very, very, very easy to forget. And the downside when you forget is you're creating and destroying all of these copies, which that, for something simple like of this, that's not a big deal. But if you're working with a large amount of very complex data, that actually can start to have some pretty major implications. It might not be safe to just be destroying the data in a loop like of that. Could also be creating a lot of overhead and memory churn there that's happening with it. It's actually really something that can be quite dangerous and quite impactful. So using that reference there removes that. We only have our looping, and it only gets destroyed at the end when the program finishes. So important thing to make sure we remember when we're working with loops is similar to what we encountered here. If we're wanting it to act like a reference, we must explicitly indicate that it is a reference. Otherwise, it's not going to give us the behavior that we're intending. It's going to create unintended copies, and that's going to be a real problem. But it lets us do things like this. We can have const auto references, and again, I can change the type of this, and I don't need to go and update the rest of this code typically. So it simplifies the code, it lessens the maintenance overhead. If for whatever reason I was using sort of the slightly older style for loop with iterators, I could have auto data it is equal to dataset1 begin. Data it is not equal to dataset1 end. And plus plus on the data it. So that works completely fine. Saves me having to write out what I would otherwise have to write is, okay, well, standard vector, simple class, iterator. So before I've even created the variable, I've already had to write a huge amount, and then I could write data it, and then the rest of it is largely the same, but this initial part gets gigantic. If it was a const iterator, then it's even longer. So it gets very messy very quickly with that. It's really not ideal. We want to try and avoid doing that. Let's see how it behaves with the iterator here though, because what I want to be able to do is I would do star data it like that. So I want to test and see, okay, are we getting any unintended copies? And it doesn't look like it, which is good. So makes it a lot easier for when we're setting these up. The equivalent of this second loop, if I was writing that out, would actually be, I would have to do standard vector and simple class and then iterator and then data it, and then the rest of it would be exactly the same. But it ends up being quite a lot more that I'm having to actually write. Now there are tricks that we can do to actually minimize that, but they won't minimize it typically, unless we're going for a very terrible naming convention. They won't minimize it as much as using auto would, or in particular using our auto with the ranged for loop. It's going to make it far simpler and easier for working with it. So the question you might have then is, should you just use auto for everything? I still would not recommend using auto for everything. There's a couple of scenarios where I think it's very good to use it. So I think using it for stuff like our ranged for loops is particularly handy because that significantly simplifies the syntax that we have to write, makes it much, much more readable. I generally wouldn't use it for simple variables like integers, but if I had, say, a function that was returning a really complicated data type, or I was constructing a really complicated data type, then auto I think would be quite appropriate there. So I use it in cases where the data type otherwise would be quite complicated to write out, And if I was going to change that it would mean a bunch of overhead for maintenance and updates. I wouldn't use it for things like of this. And there are limitations on where we can use it. So like of this, I couldn't do like of that because I haven't provided it with an actual value. And I can't do that. Auto isn't allowed as something for a member variable. It's also not allowed if I go and void test function auto input param, even if I give it a default like that, I can't use auto there. So auto is not permitted for parameters. And as I found before, auto is not permitted for member variables, even if I give it a value. So it's not permitted for member variables. Well, okay, we've tried parameters, we've tried member variables. What about a return value? Surely a return value might work. And again, good to always test these things. So let's have auto test function 2. And I'm going to, we can see there, test. So with this, well, that actually seems to be working. And let's try running it. So what I'll do is in this one here, I'm going to run data, and you can see it's not showing me up that test function 2. But let's see what happens if I go test function 2. So it's saying it's not able to find it, but test function 2 didn't mark it as const, so maybe it's being clever, and we can see that it is. Because I didn't mark that function as const, it wasn't showing up here. So let's find out, does that actually run? Now we won't get any output for it, unless what we did was we also did this. So we should expect to see test output after each data entry. And we can see it is. So we can use auto on a return value because it's going to be clear what it is, but we can't use auto as a parameter even when we're giving it a default value, and we can't use auto for member variables. So auto is really handy, it's really powerful, but it does have some limitations there that we need to be aware of. So experiment with it. See the kinds of use cases where you feel like it's going to be helpful for you to use. Test out the cases where it breaks. As I said, one of the good things to be doing when you're learning a new language is test what bits do and don't work. And getting an understanding of how to test the stuff is actually a really valuable technique to be learning, because it means that when you go into another language, you know typical things that you can test to try out for it. It also helps when you're writing your own code. You can start to think about, okay, well, how could I test that this is working? What sort of test code can I write? Because having tests for our code can be really, really handy. So experiment with it. See what kinds of things you can do. See what ways you can make auto break. See what things won't make it break. See how far you can actually stretch it without it going and breaking is something to try. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you're looking for the code for the project, it is available up on GitHub, and there is a link to that in the description below. If you have any questions, chuck in a comment below. If there's other areas you'd like to see me cover, chuck those in a comment as well. And if you're looking for ways to support the channel, then I do have a Patreon, and there's a link to that in the description also. But until next time, bye.